Hi, everyone. My name is Ken Rose. I'm a senior developer lead here at Shopify. And today I'm going to be talking to you about building apps with GraphQL. Now, before we get started, a little bit of housekeeping. If you have any questions at all during the presentation, please submit them through the Event tab. You can use the hamburger icon in the top right, select Q&A on the left-hand side, and use code UNITE, and select Track 1 Building. And we're going to be answering all questions at the very end. So I'd like to begin today by talking about Shopify's data model. This is a subset of Shopify's data model. We have shop in the middle, and a shop has products, and products have variants, and a shop has customers, and a shop has orders, and orders relate to customers. Orders have line items, and line items relate to variants. This is a data model for commerce, and commerce is complex. There are a lot of entities here, a lot of stuff. And again, this is just a subset of the entirety of Shopify's data model. Until now, if you wanted to access this stuff, you could use our admin API. It's a REST-based API, and it lets you make requests like the one seen here. You could fetch all orders, or all orders parameterized after a given date. You could create new variants, update price rules, or delete products. All of the usual CRUD operations that we know and love. Now, the title of this talk is Building Apps with GraphQL. And so I'd like to demonstrate how easy it is to build apps with GraphQL. But to do that, we're first going to build a sample app with REST to try to understand some of the issues that can occur there. The app we're going to build is meant to optimize fulfillments going to the same address. Imagine a scenario like this, where a single customer has made 2 different orders on our store. In one order, they have a butcher knife. And in the other order, they have some headphones and some walking shoes. Instead of fulfilling these orders individually, perhaps it's cheaper to put all 3 items in the same box. That leads to a treatment like this. As input, our app can take the size and the weight info of all of the variants going to a given address. We'll put those numbers into some cool algorithm that does some fancy math, and the algorithm can output the optimal size box that can hold all 3 items. In this case, the algorithm output cardboard medium. So to implement this app, we're going to need to implement 4 steps. The first is to fetch all unfulfilled orders on the shop. Group those by their shipping address to get all the orders going to a single shipping address. For each set of orders going to a shipping address, fetch all the variant info. And finally, get the size and the weight info for those variants and compute that optimal box size. In pseudocode, it looks like this. Let's step through to understand more about what's happening. In this first line, we make an API call to the orders endpoint to fetch the set of unfulfilled orders. And we receive the JSON on the right. One of the fields in order is shipping address, and that is a key that we can group on. We perform the grouping, and we now have the hash on the right. The key here is the shipping address, and the value is the list of orders going to that shipping address. And now we can iterate through those. So for all of the orders going to a given address, we will, for each order, go through the line items and pluck out the variant ID. With the variant ID, we can now make another API call to the variants endpoint to fetch all of the data about the variant, including the size and the weight info. Finally, we can put all that data into compute optimal box. Now, the only data that compute optimal box actually needs is the size and the weight information from the variant. All of the other fields on variant, its title, its price, its SKU, is all superfluous. So at this point, we are done. We have a correct implementation. But it's not great. Highlighted here are the 2 places where our code makes network requests to Shopify's API. But as network requests, these can fail. We could be rate limited and get a 429. We could have a network interrupt and get connection reset by peer. Imagine a scenario where we were processing an order with 50 line items. We successfully got through 49 of them and had some kind of an error on the 50th. An exception is thrown, the stack blows up, and we've lost all of the partial progress that we've made. Another challenge is the amount of time spent making these API requests. First, we have to call the orders endpoint, and some amount of time elapses. Only once the call to the orders endpoint is completed can we make the call to the first variance endpoint, and some more time elapses. And we call the next variant endpoint, and more time elapses. And we call the final variant endpoint, and even more time has elapsed. And what we have here is a waterfall diagram showing quite a lot of time spent making API requests. As well, if we look at the amount of data returned from the API, we've pulled down a lot of stuff. The orders JSON endpoint returned 140 kilobytes of data, and each of the variant endpoints returned single-digit kilobytes. Do you remember that compute optimal box function where I said that the only data that we needed was the size and the weight info of each variant? It turns out that those numbers account for about 500 bytes, or half a kilobyte worth of data. But we had to download 147 kilobytes of data in order to get it. So we had to download 294 times more data to get to the little bits that we wanted. So these are some of the challenges that exist when using REST. Lots of round trips, lots of back and forth, and downloading data that you don't need. So let's take a step back, and let's see if there's a better way. When Shopify released the Admin API back in 2009, REST was the best technology available for building APIs. But in 2015, GraphQL came on the scene. And last year at Unite, we announced our Storefront API. It was the very first time that Shopify publicly used GraphQL as an API technology. GraphQL had a lot of promise around efficiency, stronger typing, and superior tooling. As a reminder, GraphQL is different from REST. In GraphQL, clients send a query to the server. In this example, we're asking for the name of a shop and the URL of the primary domain of the shop. Shopify takes that query and resolves only the data that's been asked for. You can see here that the response has the same shape and is nearly identical to the original query. And the best part of all of this is that it's done in one request, in one round trip. So the Storefront API has allowed us to learn a lot of lessons about GraphQL. We have found that GraphQL is a fantastic fit when your data model has a lot of relationships, just like the data model of commerce. GraphQL solves a lot of the challenges that REST has around the size of data returned and the number of round trips. So if only we could combine the power of GraphQL with our existing admin API. Well, now we can. As Brandon announced on the main stage and Jean-Michel alluded to earlier, we now have our GraphQL admin API available to everyone here as an open beta. You have all of the functionality of the admin API with the expressiveness of GraphQL. That allows us to replace code like this, imperative code, where we spend a lot of time focusing on how to get data, or worse, in a real programming language like Ruby, all this logic and complexity. We can replace it with this, a single query that describes what data we want to get, not how we want to get it. If I dim out the bits related to pagination, this is very nearly our business logic. Fetch the unfulfilled orders, grab the line items, pull out the variant, and grab out the weight, the length, the width, and the height. Let's go ahead and see that in action. So this is Graphical, an interactive editor environment for writing GraphQL. We begin by writing the query, and note that we have auto-completion as well as built-in help documentation. We'll pull out the fulfillment status to fetch unfulfilled orders. We now go through some pagination bits, because orders can return multiple orders. Pull out the line items, which can also return a plural. And now we can specify the fields of the variant that we care about. We'll include the title there just to be able to discriminate which variant is which in the results. And we can put the rest of the fields we cared about: weight, length, width, and height. Let's run that. And we can see here in the response we got only the data that we asked for: weight, length, width, and height for the 3 variants across 2 orders. Jason Bueller, who is one of our API partners that participate in our closed beta, had this to say: the new GraphQL endpoints will help us make vast performance improvements around how we consume data from Shopify, allowing us to optimize our biggest bottleneck. It will be a giant leap forward for our customers. Another benefit of GraphQL is it has first-class built-in support for documentation and deprecation. Let's see what that support looks like inside of GraphQL, the interactive environment. So we're going to begin again by writing the query. And this time, I'm going to be selecting product. I type PRO, and I have an autocomplete list of other fields that match that prefix. I'm going to be searching for products titled Beats by Keon. And now I can go through some of the pagination bits, because multiple products may be returned. I can now start typing some fields I want from product, ID, title, body HTML. And I'm told that body HTML is deprecated and has been replaced with description HTML. I can actually pull up the documentation for product, and I can see the full list of deprecated fields that are there. Now let's say I want to add some meta fields to this query as well. I see that meta fields exist hanging off a product, and I can click through the documentation to pull up all the fields that are available in meta field. Using autocomplete, I can continue to write my query even faster. A little bit more pagination bits. And now I can put in the fields I wanted out of the meta field: key, value, and value type. I can go ahead and run that query and have this response. Body HTML and description HTML are in fact identical in terms of payload, and I got only the fields from meta fields that I wanted. Note as well that body HTML is still underlined in yellow on the query pane, indicating that this query is still using a deprecated field. So the final thing I'd like to talk about is throttling. Throttling is a requirement for our platform to help ensure that all apps have fair access to the resources behind our API. The goal of a throttling mechanism is to maintain an upper bound on the amount of load on the system. In REST, every endpoint returns roughly a fixed amount of data, and so puts roughly a fixed amount of load on the system. That means that if we bound the number of requests, we can bound the amount of load. And we do that at Shopify. For our REST API, we have request-based throttling. But with GraphQL, load is not correlated to the number of requests. In general, there's only one request. The load could be low or high, depending on the complexity of the query. So if we want to have a throttling mechanism for GraphQL, we're going to need a different approach. We could have a very simple query like this that puts negligible load on the system. Or we could have a much more complex query with deep nesting like this one. In this query, we've asked for up to 10 orders. For each order, up to 10 line items. And for each line item, get the variant, get the associated product, and pull up to 10 other variants for that product. This could return up to 10 times 10 times 10, up to 1,000 variants. Now, I said it could return that. A lot of shops don't have orders with 10 line items, or don't have products with 10 variants. So the amount of data this query actually returns, and the amount of load it actually puts on the system, depends entirely on the data that's in the shop. So this will be an important observation for how we define our throttling mechanism. So as a quick show of hands here, how many people are familiar with the charge and authorization model that are used by credit cards? All right, about half of you. So I want you to imagine you're filling up your gas tank. You go to the pump, you put in your credit card, and it'll ask you for an authorization amount. It's generally $200. And before you've pumped a single drop of gasoline, your credit limit has decreased by $200. You then go ahead and fill up your tank and put in, say, $60 worth of gas. Eventually, everything reconciles, and you'll see a $60 charge on your credit card statement. But what actually happened was your credit limit decreased by $200, you were charged $60, and then your credit limit increased again by $140. In some sense, you were refunded $140. Our throttling for GraphQL works very similarly. Given a query, we will first compute a maximum worst-case cost for that query. The way we define cost here is kind of abstract, but it defaults to 1 point per object. Objects that are more expensive to resolve may be pointed higher. We can then go ahead and execute that query. And if the amount of data returned is less than the worst-case maximum cost that we computed, we will refund any unused amount back into your throttle bucket. The actual throttling mechanism itself is a standard leaky bucket of points. The bucket can fill to 1,000 points, and it replenishes at a rate of 50 points per second. We're launching this API with a maximum query limit of 1,000, which lets you pull roughly 1,000 objects in a single request. We hope that's high enough for all of you to write sophisticated and compelling queries, but low enough to still provide fair access to resources and bounded load. So, as a reminder, we are launching this API as an open beta. We want you to use this new API, and we want your feedback. We want to know what's working, we want to know what could be made better, and we want to know what workflows to improve. That said, though this is a beta, we feel really strongly behind this API. This API has powered our mobile apps behind the scenes for the last 2 years, and it's also the basis for our new web-based admin. So going forward, you now have 2 tools for writing applications, GraphQL and REST. Shopify will still be investing in REST, and new features will be added into both APIs. All of your existing applications written against REST will continue to work. But I want to strongly encourage all of you to write new applications using GraphQL. GraphQL enables workflows that are impossible with REST. It's faster, it's safer, it's better documented, and it has first-class support for deprecation. As well, I'll point out that it's not an either-or. You can intermix REST and GraphQL in a single application. Remember that underneath it all, GraphQL is just an HTTP request to Shopify, just like REST. So if you have any hotspots in your application, places where you have a lot of round trips or a lot of complexity about how to resolve data, much like the 4 coupled REST calls that we have here, consider replacing it with a single call to the GraphQL API. If you'd like to learn more about GraphQL or get some hands-on experience, Scott and Chris will be hosting a workshop tomorrow as part of the sandbox. There, you'll learn some best practices for writing queries and mutations, how to deal with pagination, more information about throttling, and some tips and tricks for using GraphQL, which was the IDE that we saw in the demos. So to conclude, GraphQL is more powerful than REST. GraphQL comes with superior tooling, built-in documentation, and it's type-safe, which will help prevent some errors in your applications. GraphQL is more efficient than REST. You can replace chains of multiple API calls and all the associated round trips and latency with one single request. Finally, GraphQL is faster than REST. It's faster to fetch the data because you're only retrieving the data you want. As well, it's faster to implement your business logic. With GraphQL, you specify what data you want, not logic and complexity about how to get it. That means you write less code, and you let Shopify do the heavy lifting of joining related data together. So we are really excited to be releasing this API today, and we're even more excited for you to show us what you can build with it. So I'd like to thank everyone here for listening, and at this point, we will go to questions. Once again, please submit all questions to the Events app, and they will show up on the iPad I'm about to receive. Thank you. Thank you. All right. This is always the fun part. This is very dynamic. First question. When will support for the REST API stop? Currently, we have no plans to stop support for REST. As I alluded to, we plan to continue supporting both REST and GraphQL going forwards. Can I fetch all 3 million plus gift cards belonging to a Shopify Plus merchant with a single GraphQL call? No. So this is why we talked about throttling. You can pull up to 1,000 objects in a single request, and we hope that that is kind of high enough. GraphQL does have support for pagination, and if you attend the workshop tomorrow, you'll get a lot more information about how to do that. You might have seen in the demos, there was edges in Node. Pagination info is built into there, and it's cursor-based. If you visit shopify.com/GraphQL, there's documentation there on how to use pagination, or again, find any of us here or go to the workshop tomorrow. Is this query only, or can you update as well? Today I only talked about queries. Absolutely, you can do updates. GraphQL has a functionality called mutations that allow those updates to occur. And again, we find any one of us, and we're happy to talk at length about mutations, or go to the workshop tomorrow. Will responses from the GraphQL API indicate remaining quota to help manage throttling in the same way the REST API does? Absolutely. So as part of the response, there's an extension field, and that includes the amount of quota left, as well as the cost of the query that you just issued, so that you can understand how the cost is computed for your own bookkeeping. Is there any concern for errors, as mentioned with REST? I'm not quite sure what the question means. I mean, we do have support for generating errors with GraphQL. I don't have a quote for it in front of me, but one of our partners actually found that the error messages we generated with the GraphQL API were much more descriptive than the ones that we have in our REST API. Sometimes the REST API ones can be somewhat generic. So absolutely, we return errors as part of the GraphQL response. One difference is that it's not part of the HTTP code. It'll actually just be embedded in the payload itself. Again, find any one of us or go to the workshop tomorrow. I think that, Scott, you're going to be covering errors tomorrow? Yes, Scott's nodding yes, so OK. How does posting new objects work with GraphQL? Again, mutations are the way that you can kind of create or update resources, or pardon me, objects within the graph of Shopify. So that's how it works. Let's see. Will GraphQL return our bucket's current number of remaining tokens, or how can we keep track on our end? Yes, again, the extensions, the extension that we added to the response has that data in it, so that you can see how much kind of query capacity you have available. What tool are you using to publish your GraphQL metadata? I'm not sure what you mean by metadata. Yeah. I can't hear a word you're saying. I'm so sorry. But I'll tell you what, why don't I find you afterwards, and then we can chat about it offline. All right, a couple of incoming questions. If products use the maximum of 100 variants, would that mean fetching 10 products with all variants consume whole throttle limit? Plus or minus a few connection field things? Yes. Will the throttles on REST and GraphQL APIs have awareness of each other, or will they work independently? So that's a very interesting question. Currently, they work independently. We're still kind of exploring because we don't want to melt our servers. We need to ensure that those throttles are there to help bound that load. But currently, the REST throttle and the GraphQL throttle do work independently. 502 gateway timeouts are commonplace with the REST API. How does GraphQL fix this? I'm really sorry for anyone who's experienced 502 gateways. That should definitely not be the norm. I'd be happy to talk to anybody afterwards about the experience that they've had with it, because a 502 means an app server is unavailable. GraphQL won't necessarily help with it, but you shouldn't be getting 502. So I'd love to find whoever asked the question, and we can chat afterwards to see how we can make that problem go away. Can GraphQL search by product or order tags? That's a good one. I actually don't know off the top of my head, but please come find me afterwards. Yes. Yeah? OK, yeah, my friends in the back are saying yes, so yes. GraphQL sometimes is timing out. Any idea why? Without seeing your query, no, but come find us afterwards, and we can look at it, and we're happy to help you debug to see what's going on there. What's the best way to migrate an app from REST to GraphQL? So this is a really interesting question. So as I alluded to, you don't have to have this big bang, OK, we're going to replace every call in our app right now. I would start with certain areas that have hotspots, or you do have a lot of back and forth. But you'll find that all the entities that we have in the schema pretty much match what we have in our REST API. We did make a few small changes to kind of smooth off some rough edges that existed in API. So it's not a perfect one-for-one like mapping from REST to GraphQL, but most of the big pieces are there to make it a pretty straightforward translation. Has the throttling model been tested on Shopify's implementation of GraphQL? It has, and it's working so far. So again, if you have any concerns around throttling, this is why we want you all to use these APIs and provide us feedback. If you find that the throttle limit is too low for your applications, please let us know. Can we launch apps to the App Store in GraphQL? Yes, if you're asking, can you launch apps to the App Store that utilize the GraphQL APIs? Absolutely. In fact, I encourage you to do so. It'll make your app experience a lot better because you're performing way fewer round trips. Is the throttle bucket independent from the REST throttle? It is. We talked about that earlier. Can you talk about GraphQL clients a bit? Apollo versus Shopify client? Yeah. I don't have much info to provide here, but I'd say come find one of us afterwards, and we're happy to talk. Yeah. Will Shopify open source GraphQL clients in Go? I currently don't know that we have any plans to, but if we do write a GraphQL client in Go, I'd be remiss to understand why we wouldn't open source it. We've made a ton of open source contributions in the past, and we'll continue to do so. Is the entire REST API covered? Anything missing? I don't know off the top of my head is everything missing. We've tried to get as close to parity as we can with the REST API. But again, the same message here. I encourage all of you to use the API. And if you find anything missing from the GraphQL schema, please let us know, and we're going to be happy to add it. It's why we want to have this beta program with all of you here. A couple of repeat questions. Are you going to add GraphQL to a Ruby gem like current REST? No current plans to yet, but we'll see. It's definitely a fantastic feature request. And again, please provide us that feedback as well through shopify.com/GraphQL. Will throttling be different for Shopify Plus merchants? Unfortunately, no. Currently, the throttle limits that we have are really there to help protect our APIs. It doesn't currently matter if it's Plus or not. But again, if you do find that you have a need for that, please contact us, and we can try to work with you to understand the amount of data that you're trying to pull. It seems like the rate limit is lower than the REST API, 5 requests per second with up to 250 results versus 1,000 objects per request with 50 per second recovery. Again, please, yeah, that is a good observation. I'd love to see you try to use the API and see if it's satisfying the use case that you have. And if you're not, please provide us the feedback to say like the exact use case you have. And we're happy to work with you to try to tune the throttle limits appropriately. I believe that's everything. So I'd like to thank everyone here once again. And please adopt GraphQL and start using it and let us know how it's working for you. Thank you very much.